We might edit that out. I don't know.
Oh, right.
There's Purdue behind me. Hello, my name is Bill Oakes. I'm the director of the EPICS program that's headquartered at Purdue University. I want to give you an overview of what EPICS, the EPICS program is, why it got started, the motivation, and a little bit about what it is. If you look at some of the motivation for when EPICS was started, and the motivation for you to adopt an EPICS program yourself, there are two big categories. And one of them is when we talk about the attributes of what an engineer is or should be for the future. What is it that makes a globally competitive engineer? What does it take to equip somebody to be a leader in the global economy? The U.S. National Academy looked at this and they talked about the Engineer 2020, which isn't that far away now, but they talked about the attributes of the Engineer 2020, the leader for that global economy, and they talked about both strong technical skills and this broader set of what we call professional skills. And one of the challenges for us in engineering education is how do we continue to add to that technical curriculum as we have more and more, the technologies are invented more and more that we have to cover, and add these professional skills. And that's one of the things that we can do with EPICS. The other big driver and piece in this is the research and learning, is when you look at how students learn and how to learn most effectively. And the compelling evidence there is engaging students in active learning, experiential, getting them involved in experiences, projects, and that coupled with reflection, metacognitive cycles about those experiences are the way to maximize learning. Also, when you look at, in addition to the National Academy, industry has been calling for a different type of engineer for quite a while. And if you look at the attributes, this is a list that actually was created by the Boeing company that has been adopted by several other industries. Boeing did this hoping that other companies would add their list, and what actually happened is most people looked at these and said, that's an excellent list that we actually want to point them. This list was a precursor to the ABET, the accreditation standards that are common now. And again, they talk about that strong technical background, engineer that's good in the fundamentals, but has those broader sets of skills. As you see, it includes things as teamwork, leadership. Actually, the last thing on the list, it talks about a profound understanding of the importance of teamwork. Teamwork, the ability to work across global and multicultural teams, is an example of those broader skills. Now, a little bit from my own story, I came out of industry, a job I loved and enjoyed being a design engineer in industry. I thought that there was opportunities to make more of an impact for me at the university. So I left left industry, came to the university, and wanting to help train that future professional. Now, when I came to the university, my vision for that was I was going to bring industry projects that looked like what we did in industry down in the classroom. And that changed my first semester when I was assigned what I thought was just a little side class called EPICS. At Purdue University, EPICS had been going for 3 years. It was a smaller class. I thought it might be fun, but it wasn't real engineering. And what flipped my thinking completely on its head was when I saw how the students were responding to designing homes for lower income people, that I looked at creating exhibits for a local science museum, that hands-on activities for small children. When I saw them doing therapeutic toys for children with disability. My background was actually in gas turbine jet engine design. And when I saw what the students were doing, I realized they were doing things that I used to do and my colleagues back in industry. They were actually doing engineering. And that the key piece was, what EPICS does is we partner with nonprofit organizations that do not have engineering organization. They don't have an engineering staff. They don't have anything to fall back on. They're interested in our product. They're not interested in recruiting our students, being nice to our students. They actually want something that works. And so they treat our students like real customers. And what I saw as the students responded to that is they had to respond like professionals. Too often when we do industry projects, we have to strip out some of those key elements that provide the critical learning. As educators, we don't want learning experiences that look like what they'll do later. We want learning experiences that provide the fundamental skills to our students to end up doing those industry, corporate, or nonprofit type jobs. That's what drew me into EPICS. And I'll share what has made EPICS my passion, but the industry preparation, it is a key part. Now, what I do as part of my faculty position is we do research on engineering education. And so we've actually gone out and studied what EPICS does to our alums, and an example here is one of our alums that talked about how the EPICS actually prepared him to be a leader once he got into industry. And we have other evidence, literature, and testimonials to that effect too. And I said I'd share what has made EPICS my passion. What drew me to EPICS was the ability to prepare future leaders, make engineers better. And that is what keeps me teaching that. What gets me passionate and traveling all over is also the opportunity, if we look in our societies, and we look at the limited budgets that we have societally or for a government, we have the educational and industrial enterprises, and we have the needs of the underserved. And if we have to look at these as choices, it can create conflict within our society and conflict in budget. But what EPICS does is look at the needs of the underserved as opportunities. And those opportunities are to get students to look at solutions. And those solutions can often end up back in products, in commercial type products. And even if we don't make a lot of money, what we're doing is we're leaving the world a better place. People can invest in our educational institutions and see that the needs of the underserved are better. We have tremendous capacity globally in our educational institutions that is not being leveraged to make the world a better place on a daily basis. Just imagine if we could harness all the energy and expertise of all of our students on campuses. So while they're learning to be a better leader, a better corporate leader, a better corporate citizen, global citizen, that they're leaving the world a better place, our local communities a better place, we could make a significant difference globally. That gets me passionate and excited that you're viewing this video. Now, in EPICS, we started the courses here at Purdue, and we've had a lot of success, and we're intentionally sharing the model, and we do that to share some of our lessons that we've learned. So if you're looking at this, you don't have to relive all the mistakes that we have. We're also trying to create a global community of like-minded faculty, students, community partners that can work together to help all of our students learn better, be better prepared, and to leave the world a better place. We're interested in collaborations. We're interested in exchanges. When I talk to corporate folks, they're very excited about these ideas of having students in different parts of the world, different parts of any country, collaborating together and learning how to do that, because that's what their employees need to do on a daily basis. And EPICS offers that. Now, when we think about what makes EPICS, we don't have a list of requirements. We think in terms of a set of core values. And these core values, we have 3 core values. And they're listed here behind me. Students earn academic credit for team-based projects where they solve some kind of technology-based need in the community. So they're doing a design, they're doing it with others, and it relates to technology, engineering, computing in some way. And our EPICS teams provide some service, tangible service to either the local or the global community by partnering with nonprofit organizations, NGOs. Now, I will say that the community can be your own institution. We here at Purdue have teams that are partnered with our own university, looking at how you make the university climate, culture, whether it's in the classroom or the campus environment. It is a great way to start. It has the advantage of not worrying about how your students get off campus. But if that's where you want to start or you want to add that, that is perfectly fine. And the service that we provide is not in hours students spend out in the community, it's in the products that we're going to design. The final value or set of values is our students, our EPICS programs support these things in what we would say is reciprocal partnerships, equal partnerships over multiple years, where our community partners are partners that they help our students learn, and they are co-creators of the products. So they are engaged in that. We'll talk later about our model for design on how do we do that. Too often our community in higher ed has looked at partnerships in terms of projects. I want to get this one thing done. When it's done, we'll drop it off to the community and we're done. And what the community needs is once that project's delivered, we need to say what's the next thing that could be done. And by the way, we will go back and we'll support that initial project. That's what we're talking about long-term partnerships. We have a number of universities that have engaged. We have over 20 universities that call their classes EPICS classes. We have a larger number that have taken some elements of what we do and form their own program. That gets us excited too, and we're happy to work with you with that. We have a number of high schools, pre-university programs within the U.S. and abroad. We have a partnership with IEEE. There's an IEEE EPICS that blends university and pre-university students together that has over 30 programs going on all over the world. EPICS, we offer workshops and conferences in different places. Often, every year or two, we have something at Purdue, and we host them in different parts of North America and globally. We share curriculum. We have things up on the website, both the Purdue program's website, and we have the University Consortium's website, where we like to share things freely. We try to build a network of faculty and professionals, and as I said, that are like-minded, interested in similar type things that we can share best practices and ideas. I want to share a little bit about the different projects that we have. When we think about projects, we don't talk about them in terms of electrical engineering, mechanical engineering, civil engineering projects. We talk about them in areas of impact, and we have 4 areas of impact: access and abilities, working with adults and children with disabilities; education outreach; human services; and the environment. And some examples of each of these in access and abilities, did a lot of work with in education and communication for people with disabilities. Custom prosthetics, often people with disabilities need some customizing around accessible devices. We've worked on physical things. The bottom has an example of a little race car. We're produced in Indiana, and we've got the Indy 500. Racing is kind of important to us. And this is an example of a soapbox derby car that was designed to allow a child with a disability to ride in front and get the experience of that race with an adult driver in the back to keep them safe. Some other examples that include IEEE examples. This was an example from NIT in Warrnambool, where students were looking at smartphones and other kinds of devices, looking at how they could be adapted for children with cognitive disabilities. Another example from India was looking at education settings for children with visual impairments. That how do we look in classrooms for people who may be visually impaired or blind. And this other example looked at taking a webcam, and for somebody who may not be able to speak, could we look at gesturing? Could we look at the webcam identifying gesturing or sign languages or other messaging, and could they communicate that through a webcam? Human services, we work with NGOs. We do quite a bit of IT work for NGOs. We've worked with local law enforcement organizations, first responders, with those to make their job easier. We've looked at organization that's Global Habitat for Humanity, is looking at their home designs to make their homes more energy efficient and affordable. Now, some of the projects, too, intersect research, and this is actually an example of a faculty member in computer engineering that has integrated his research with a community need. And his research is in image recognition. So what he's got students looking at is, could we take a picture of a plate of food and it give back the person the nutritional information? So we're looking at image recognition, state-of-the-art image recognition, and he's integrated his graduate students with his undergraduates. If I look, some other things around human services, this is an example from one of the IEEE partnerships in India, where they were looking at the traffic control system and how do we synchronize traffic signals during different parts of the day to optimize traffic. If we look at the environmental projects, again, this is an area where we've got a lot of projects where students will look at the campus sustainability, look at environmental demonstration projects on their own campus. We've got what we call a Boiler Green initiative here at Purdue's campus. And we've looked at rain gardens, green roofs, alternative energy within the campus to lower the cost of the campus, and also to create demonstration projects for the larger community. Sometimes that our campus administrators are easier to convince that we can do a demonstration, and then we can disseminate that information out to the larger community. We've got teams looking at water issues, water resource, purification, management. We've got them looking at alternative power. We have one team that's looking at remote villages in a Latin American country, in Colombia, how to provide solar power so that the schools have power during the entire day. Looking at solar power, so power examples can look at one of the IEEE projects, looked at a solar-powered cart, and this actually intersects with the access and abilities. It is, can I look at a solar-powered cart that was accessible by a wheelchair? In the education area, and I want to clarify, when we do projects in education, we're not sending our students off to talk to younger children about how cool what we do is we're trying to partner with the education and institutions, whether it's a school or museum. What could we put there? And it could be a Mars rover that the children can play with. It could be hands-on activities for a local school, a museum. We've got the Purdue Space Day. It's an outreach day for our campus. Other institutions may have it where you invite children to campus to learn about some of the things that you do, and designing devices that support activities is a great design. I personally am a fan of the education projects as a designer, because I believe that small children will find any flaw in a design very quickly, and students learn about safety, reliability, usability, and other issues. Now, it can be a device that they use, or it could also look at infrastructure. So this is an example of an IEEE project where they looked at a remote, an affordable remote conferencing system that would allow other people with expertise to beam in or to be broadcast into a classroom, and to allow children in a remote village to have access to expertise they wouldn't otherwise have. That's the overview. We'd be happy to continue a conversation with you, either on the website. There are other modules on content issues that you have, and look forward to hearing from you. You just edit the other to close. It takes a little bit. Hi, I'm Bill Oakes. I'm the director of the EPICS program that's headquartered at Purdue University, and I want to give you an overview of the course and curriculum that we use in EPICS. Now, one of the first things that I have to say is EPICS looks different at every institution where it's implemented. So I'm going to use some examples that have been successful at Purdue, where we teach, and other places, but you need to feel the freedom to adapt it to your own institution. The graphic behind me kind of kind of shows that we've got curriculum pieces that can provide some guidelines and some tools, but it has to be adapted based on your own culture and your own community. When I think about that, I think about the Purdue EPICS characteristics, and I want to stop with a disclaimer here. The disclaimer is at Purdue, we started in 1995, so we've been doing this for quite a while. EPICS has grown to a very large course and a structure. And so when I talk about some of the examples, I don't want you to think that you have to get to where we are and have to implement all the characteristics right now. Again, part of adapting to your own culture, as I showed back here, is figuring out where it's appropriate to start. But when I look at the Purdue characteristics, we are what we call engineering or computing-based design. We are multidisciplinary. We're very multidisciplinary. We had about 70 different majors participate. In a typical year, we're between 70 and 80% engineers, but we intentionally talk about engineering-based design because all of our designs involve technology in some way, and they are all designed, but we don't want to scare away students from business, liberal arts, and other majors because we need them for the design. We have long-term partnerships. That is one of the characteristics and one of the core values of EPICS. We have some of our original partners and several of our partners back from the 1990s that are still with us. A benefit of that model for faculty is you don't have to go recreate and find projects. This year we had about 90 projects, a little less than that, starting in the fall, and I believe that there were about half a dozen projects that we as administrators were involved with. So we had over 80 projects that continued into this year without our involvement, just based on the partnerships and with the student engagement. At Purdue, we are vertically integrated, which means we have first year, second year, third year, fourth year students that we mix. They take courses and they're all mixed together on the teams. Those first year, second year, third year, fourth year students, again, come from 70 different majors. And our curriculum is set up so we have an extended design experience. Most of our students take EPICS for at least 2 semesters. Many of them take it for 2, 3, and sometimes even 4 years. The outcomes that we have for our Purdue EPICS class are shown behind, and these outcomes come from the ABET, our accreditation criteria. The accreditation criteria for engineering, with one exception, it is, you see, we've substituted the word engineering and technical for in your discipline. So when a student comes from business, they're assessed in our program, and the learning is based on how they apply their knowledge from business or management to the design of the community-based projects. Understanding of design, identification of new knowledge, etc. So these outcomes are the learning outcomes for all the students. Now, I'll emphasize this, but I want to say it explicitly. In our course, the learning takes place based on the project work. And we don't have a lecture theoretical set. We have a few lectures to introduce students to our concepts. But these outcomes actually derive from the project work and the learning and the reflection and discussions that we have within the project work. Our course goals that we talk at Purdue, we talk that students will experience multidisciplinary design. And by the way, in our accreditation criteria, multidisciplinary teaming is explicitly listed. Often we don't, in the US, we don't think in terms of that in a classroom is within and outside of engineering, but that's the intent for industry, and that's the intent that we have. Professional preparation, the things that we do and the practices that we have are modeled after getting students ready for what they're going to do after they graduate, prepare them to be professionals. And with service learning, we are providing a service to the community, and the students are learning valuable things that are going to make them effective professionals. Our course structure is set up. Now again, this is one model, and this is what we use at Purdue, and there are other kind of models, but for us, at Purdue, we have a 2-hour lab. where the students all meet together. And that is essentially, when you think about it, as the course. Me as an instructor, and we call the instructors advisors on our campus. That's the time when I have blocked off to meet with the students and all the students are there. Now, as any course, we expect students to work outside of class, kind of their homework. So they don't have homework assignments, they need to continue to work on the projects. On our campus, we have students to register for 1 or 2 credits, and they're on the same team. And the way we distinguish those is the outside of work, the outside of class part. Is a 2-credit student would still go to the lab just like the 1-credit student, but they're going to do twice as much work outside of lab in between classes. And then we have a set of what we call learning activities. They can be lectures, what we call skill sessions, where students may learn soldering, teamwork skills, learn some software packages, or workshops where we do something more extensively, or we could have industry people come in and talk to them. They're required to have 5 of these if they're 1-credit students, and 10 of them if they're 2-credit students. I try to translate these learning activities into what I need to do as a professional engineer to keep my license updated in professional development hours. Now, some models that we've kind of broken, academic models that we've had to break. There are a number of them, and I want to talk about the time scale issues, because what we tend to think about is a student comes into your class, they don't know anything at the end of class, that they're perfectly informed, fully informed, able to go. If I do a project in the class, it starts at the beginning and it goes to the end, and magically it ends right when the semester ends. And that's great if everything goes as planned. When we're doing community projects, there are things that are going to come up that we can't plan for. And the thing that happens often is I've got students that are learning, and I've got projects. What happens if that project's not finished? And what we have in our structure is we allow students to come into our class at different semesters. Most students take our class for more than 1 semester or academic period. And what that does is it allows us to decouple the semester timeline, academic year, from the project timeline. So projects can begin and end at any point in the semester. The graphic here shows a project that was started by a student. It ends in the middle of this semester that's carried on with the second set of students. And so during the semester, the next project begins. And so at whatever time that you're watching this, we have projects at Purdue that are ending and starting during the semester. A key part of that is 2 key parts. It enhances the learning from the students because they get to see the entire cycle and they get to work on it until it's finished. A big part is this bullet down here is the community receives the support that they need. If the semester ends and the project's not finished, we can't just give it to the community and say, wow, you got to go finish it yourself. They don't have the expertise. And so this allows us to continue to work on a project until it's finished so the community receives what they needed. Now, to manage this, and you may say, well, if the project's not finished, how do I grade them? Because in a traditional project, they get the big grade based on the fact that they finished the project. Well, what we do is every semester, we work with the students to do a timeline, an example shown here for the semester. So whatever our students and myself have agreed to be done by the end of the semester, that's their grading scale. That's the expectation that they've got. And the timeline here, you notice that it's grayed in. So this shows things that they finished, and then other things that they haven't. So each week when we go through, we look at their timeline and look at their progress. Are they ahead? Are they behind? And they can help manage. This gives them great project management experience. I have to laugh because I have students that will ask, who in their right mind can figure out what we're going to do for the year or the semester before we've done it? And how do we know how much it's going to cost? How can we do a budget and timeline? And students will question that until they graduate and they get their first job and they come back and they say, Professor Oakes, I'm so sorry. I realized the answer to that question is that every project starts with a project plan and a budget. And that's what we're trying to train the students for, is to be leaders once they leave. Now, when I think about the semester plan, the other timeline was related to the project, but each semester we break the semester into 3 different kind of sections. And the first part of the semester is always planning, because we have new students coming in, they have to be adapted, and we're developing the plan. So some project work happens up at the beginning, but we're also doing some planning. Now the students get frustrated often at the beginning of the semester because they want to be building. That's what happens in the middle of the semester. Toward the end of the semester, we need to be looking, either we think the project's going to be finished, but if it's not going to be finished, we have to be documenting so that we can leave the next semester with enough information so they can pick up where we're at. Now, one of the things that we found is we do not allow students to deliver a project right at the end of the semester. And that's just because the community has asked us not to do that. Because too often a project is delivered and then something goes wrong and the students are gone. So we actually back it up where the students have ideally 4 weeks, but never less than 2 weeks, where they're still on campus when the project is delivered so they can take care of things. Sometimes that does mean that on our campus we'll delay delivery to the following semester so the students are there. And the community has said that's actually preferable. Now with these project timelines and all this, what we found is students are still used to, is there a list of things that I have to turn in? And so another document we provide students, and this is an example from a little bit ago, is here's what I have to turn in. So we have a list of deliverables for the students, like assignments, but then we also have the things that they have to do relative to the project. In EPICS, we teach what is called a human-centered design approach, and the human-centered means that we put people in the middle, stakeholders. Who are people who are going to be impacted by the design? Human-centered design is one of the things that is being talked about as a key element in engineering education. Is how do we make students globally competitive is they have to understand the human-centered design, how people are actually going to use it. And EPICS and the community-based projects becomes a wonderful environment for them to apply those skills. Because the community often doesn't know what they need. And human-centered design principles include an early focus on users, so our students have to understand the community. Designing with the users, so engaging them in the process, measurement and evaluation and iterations through the process. We have to understand who the stakeholders are, what information that they need, what are effective ways to get that information. And I'll talk about one of the things that we teach is prototyping, so the students can build something to get some information. And how are we going to measure if the goals are met? The community projects are great, but often our community doesn't know what they need until they see it. And then we have to understand which of the stakeholders are involved in the process. Now I talked about prototyping, and as an engineer, when I think about a prototype, I think of something that's working that essentially looks just like the finished product. And that can be a type of prototype. But we also want to do, as part of the iteration, can we do intermediate prototypes that are fast to do where we can get information back? IDEO is a internationally recognized design firm, and one of the examples for them is they were developing a surgical device to do nasal surgery. And they were hired by the company, and this is actually the finished product. But early on, they contacted the company that was contracting them, and they said, we have an initial prototype, and what they actually showed them, sorry, don't know what button I hit just there. This was actually the prototype. Now, I will have to caution, if you use these slides or use this video, you're going to have to explain to students what the black thing is. That's actually a film canister. So when I talk to my students and I mention film, I have to explain what film is to them. But it's a clothespin film canister and a marker. And for this case, the state-of-the-art, all the existing devices had the handle in line with the actual device. And what the design team said is we think that we need a 90-degree, which is what they went to. But they did this prototype so they could get feedback from some of their stakeholders on, will this actually work? And once they figured out that concept, It drove the final design, and by the way, the entire industry went to the 90 degree after they did that. These kinds of prototypes are great for soliciting information over the community. It's one of the things that we teach the students. And prototypes could include visual representation. If I'm doing software, I might do storyboards on paper. I can do drawings. I can do a functional mock-up. But getting students to do prototypes to get information that then feeds back into the design is important, not only to get the community project correct, but for their design education. Now, a little bit about how we're structured. We have our teams, our classes are student run. So at the top here, we show a project manager. And that project manager is the team leader, that they're in charge of the class. When they come in, they're actually running a team. Now, power for this is students that then go and they interview and they go into industry. They've actually led a design team. Not just a class and pretended, they've actually led a design team. For each project, then, we have design leaders. Now, the idea here is that project leaders worried about those timelines. The design leader has primary responsibility to make sure the design is good, perfected, or good enough for the community. In a company, there's a little tension between the project people that want it done and the designers that want to continue to iterate until it's perfect. And we try to set up that tension or just students that have different voices so that we can determine when is a project ready. I will say there's a mistake that we can fall into is trying to get the design so perfect that the community never gets it. And often it's better to deliver version 1.0 to the community than work on version 2.0 and deliver that so that they've been able to use the first version. This shows a typical class would have me as a faculty advisor or somebody else truly advising. So I will sit back and add my guidance when needed. Often students need to experience something. The visual that I use often as an advisor is if I know students are headed for a cliff or for a mistake. Often, some students, you can tell them the cliff is in the distance and they believe you. Others have to get right up so that they see it. So sometimes students need to run through some of their ideas. Other times that you can say, and that's part of the art of teaching. There's not one answer to that. But I try to stay out of the way if things are going well. We have other roles too. We have a webmaster for every team. A website's great to communicate. We have a community liaison. Our community partners don't want every single person texting or emailing them. They want a single point of contact. And then we have a financial officer. On our campus, we have a certain amount of money that teams can pull from, and the financial officer is the one that manages that budget. We have students that put together design documentation, so there needs to be something related to the design. We have a server system. We actually use Microsoft SharePoint for students to upload their documents. These documents are ones that are going to stay with the projects. So if a project is delivered and 3, 4, 10 years later it needs some service, there's documentation that the students can read. On a semester basis, it's going to have their project plan. We run students through design reviews twice a semester, and the feedback from that is also in that. Part of the learning that goes into this is the students need to, part of the learning needs to be made explicit to the students. We may believe that students are learning certain things, but if it's not made explicit to them, a great learning opportunity can go right past them. So we have the students write reflections each week on how the project's doing. What I tell the students is I want to see your thinking. I want evidence of your thinking. And so one of the things they're graded on is their critical thinking. And it can be the decisions they have to make on a project, what they think needs to be done next, how the team is working, about the community project, a number of different things, but they need to write on those. We will have students do that weekly. We also have students do a final reflection at the end of the semester. This is a way to get them to synthesize what's happened in the semester. It's a wonderful way to collect data. from the students to get a snapshot of what's going on. That's kind of a high level of how we run the class, some of the key points. There's more information on our website, and there's more information on some of the other modules that you're welcome to see. Thank you.